The first one is this. 1. Angles in the same segment. Angles in the same segment are equal. Alright, let's try and show you how you get angles in the same segment. Let's try and show you how you get angles in the same segment. I'm drawing a circle. And remember I told you that a line, a straight line that's drawn across the circle that touches the circumference at 2 points is called a chord. Now the chord divides the circle into segments. So the bigger piece is called a what? Major segment, and the smaller piece is called a minor segment. Alright, let me draw the first angle in the segment. So I'm going to draw an angle in the major segment. Then I'm going to draw a second angle in the same segment. Alright, these two angles are equal, and the reason they are equal is that they are called angles in the same segment. So let's A, B, let's make this C, and let's make this D. If this angle here is theta, this angle here is also theta. So I could say that angle A, C, D is equal to angle A, D, B, angle A, D, B. Both of them are equal to angle theta. Why? They are angles in the same segment. Alright? Angles in the same segment are equal. Some basic characteristics. Please note, the two angles are formed at the circumference. Notice that angle D and C and angle D, they are formed at the circumference. Note also that the angles have the same starting point and the same ending point. Please listen. So the two angles start at A and both end at what? B. And the two angles are formed at the what? Circumference in the same what? Segment. Angles which are so formed are called angles in the same segment, and angles in the same segment are equal. If I want, I could put in another one. Start at A, go up to the circumference, come back down at what? B. Let's say that this is E. This angle is also angle theta. They are angles in the same segment. I could put in another one. Start at B, go up to the circumference, and come back down to A. Let's say that this is F. This angle here is also theta. They are angles in the same segment. So what can we say about them? First of all, they have the same starting point and the same ending point on the what? On the circumference. And both of them, the angle itself is formed at the what? Circumference in the same what? Segment. Angles in the same segment are equal. This is the first one. Let's have a look at the second one. Alright. The angle in a semicircle measures 90 degrees. Or the angle in a semicircle is 90 degrees. The angle in a semicircle is 90 degrees. Alright? So, let's draw a circle. Alright? This is the center. What do you call a straight line? What do you call a straight line that passes through the center of the circle, that touches the circumference at 2 points? What do you call a straight line that passes through the center of the circle, that touches the circumference at 2 points? It's called the diameter. The diameter divides the circles into two equal halves. A half of a circle is called a semicircle. ladies and gentlemen, the angle in a semicircle is equal to 90 degrees. Let me show you what I mean by angle in a semicircle. So you start at the what? Circumference and the diameter, up to the circumference, then back down to the other end of the diameter. This angle here must be equal to 90 degrees. It is called angle in a semicircle. Let's draw another one. You start from one end of the diameter, up to the what? Circumference, and back down to the other end of the diameter. This angle here must be equal to 90 degrees. It is called angle in a semicircle. Angles in a semicircle add up to is equal to 90 degrees. Let's put in another one. One end of the diameter up to the circumference, down to the other end of the diameter. This angle here must be equal to 90 degrees. It is called angle in a semicircle. Would you agree with me that down here is also a semicircle?
Yes, sir.
Talk to me now. So if I do this, and then like that, how much does this angle measure? Talk to me now.
90.
This angle is 90 degrees. It is angle in a semicircle. Ladies and gentlemen, the angle in a semicircle measures 90 degrees. Alright, essentially what we want to do is we want to go through them as quickly as possible, and then you can see how they apply in a question. It's a topic that within a short time we can quickly master it. Alright? Just keep on writing. Let's put in the third one. Third one. The angle at the center is equal to 2 times the angle at the circumference. The angle at the center is equal to 2 times the angle at the circumference. Right, let's see if we can illustrate that. A circle. Alright. Alright, let's draw a little chord. You don't even have to. But A, B is a chord. Alright. This is the center of the circle. So let's say the center of the circle is O. So angle AOB is an angle that is formed at the center of the circle. Angle AOB is an angle that is formed at the center of a circle. Alright, let's form an angle. Same starting point, same ending point, but this one goes up to the circumference. Alright. Same starting point, same ending point, but one goes up to the circumference. Alright, so let us say that this is C. Alright? So what this third theorem says is that the angle at the center is equal to 2 times the angle at the circumference. So for example, if the angle at the circumference here is theta degrees, the angle at the center would be equal to what? 2 times what? Theta. The angle at the center of the circle is equal to 2 times the angle at the circumference. The angle at the center is equal to 2 times the angle at the circumference. What else? Please note that what? Both angles have the same starting point and the same what? Ending point. One goes to the what? Center, and the other goes to the circumference. The angle at the center is equal to 2 times the angle at the circumference. Let me ask you this. If I did this, let's say that this is D. Who could tell me what this angle here at D is equal to?